This is going to be a movie on how to perform the simulation, solid edge simulation portion of the Ironeagle demonstration. And in order to do the simulation, what you'll want to do is come to the Configurations pull-down menu and go to the 09 Simulation tab. And what that's going to do is it's going to bring up one of the hubs and the shaft and the blade. And so for that, what you'll have to do is scroll down toward the bottom of the tree, and you'll notice that there's a 701 assembly. Expand that, and under 701 at the bottom, there is another assembly, 02602. Expand that, and then underneath there you'll find this particular assembly. And what we want you to do is just simply go down and come into this assembly and use your Open option to open up this particular file in its own assembly environment. Now once you get in there, it'll probably be set in Pathfinder to the Home tab and to the Pathfinder tab. We want to point out that this is a new environment for Solid Edge with Synchronous Technology 2. So we've added the Simulation tab, which has a full complement of tools to run different types of analysis. And we also have added the Simulation tab to Pathfinder. Now in Pathfinder there are 3 studies already generated, so you really don't have to create a new mesh and then solve it to get the results. The results are generated already for all 3 of these particular studies, and we do that in order to cut down on the time. Now if you happen to reset the modal study and run a mesh and solve, it takes about 17 minutes. The static studies take about a minute to a minute and 20 seconds. So if you want to rerun them for any reason, you can. A minute and 20 seconds is not that long to run the static study if you'd like to redo it live for the prospect or customer. Now what I like to do in Pathfinder is come over to this Show Single and click on that, just so that I'm showing the active study. And you can tell which active study is because it's turned to a blue text instead of black. And then you can scroll between the different studies if you need to. So with Modal Study 1, this is where we'll start the demonstration. I also like to tell them that you can create a new study. We already have 3 created here, but you can create a new study, and when you do so, it does give you options for 3 study types: linear static, normal modes, and linear buckling. And then of course you've got the different mesh types for tetrahedral, surface, and of course mixed if you're in an assembly. So we offer those options. Now the first thing that we're going to do, of course if you hadn't already done it in an assembly, is define the geometry, but it's already been done for this particular study. And we've already defined the constraints and the connectors and the loads for each one of these studies, but we want to show them a little bit. So what I'm going to do is just come up and roll the model over and say, well, you know, what we want to do is apply a fixed constraint. We're going to apply a fixed constraint to this bottom face of the hub, and then right mouse button click to accept it. And you can see that it gives you graphical feedback of where that constraint actually is. Then I come over to Pathfinder and just simply turn it off. At that point, we also want to show them how to define connectors. So I'll click on the auto connector. We're going to leave it at glued. Everything default here. So all I have to do is just simply select all components, click on that particular option and accept. And the first time that you accept this in this file, it takes about 15-20 seconds to capture that information and set up the actual connections between each of the parts. When that's complete, it will list the parts in the results section here. So we'll just wait on it. And when that's done, we can scroll down and it'll actually highlight the different connections that it's created, but we'll go ahead and accept, and it will add those connectors to our study, and then you'll want to turn those connectors off. Then click on the mesh button, and when you do, it's actually going to bring up the mesh that was previously done. So you don't actually have to mesh, click on the mesh or the mesh and solve. You can, however, click on the solve if you'd like to kind of just show them how it runs, but I would suggest canceling it after you kick it off, just to show them that, and then go right into the results environment. Now with solid edge simulation, the results is its own environment, and you can see that it has its own tabs to get different types of feedback that you might want to look at. When you run a modal analysis such as this one, it's going to show you all 4 modes, and you can look at each one of those modes by selecting it, or you can use the down arrow and just click on the down arrow and it'll take you to mode 2, or down again and it'll take you to mode 3. So it does give you feedback as to the displacement at each one of those frequencies that have been created. So that's kind of the feedback from the modal analysis. What we want to do now is run a static analysis. So we're going to go to the next study, which is the static study 1. One thing I also want to point out in Pathfinder, because we've already run these analyses, and when we go through and define new constraints and force, even though we're not actually using them, it does put a bang mark in front of the mesh and the results, and you're just going to have to ignore that or collapse it if you don't want to look at it. But in this case, what we want to do is we want to go ahead and use a fixed constraint. So again, we're going to show them how we're going to apply a fixed constraint to the bottom face of the hub, but we also want to simulate this blade hitting some ground or a rock. So we're going to go ahead and apply a fixed constraint to this left side of the blade, and then we'll accept that. Once we've done that, then I'm going to zoom up on the blade, and we might want to apply a force to the front edge of this blade. It's going to put that at an angle. I'm going to key in a value of, say, 1000 and just hit the tab key because you don't want to get out of the command. And then you can use the steering wheel to lock to different faces to change the direction of the force. By holding the shift key down and selecting the blue plane, it will putting it flat on that face, and then I can select that secondary knob to get it going in the direction I'd like, and then a right mouse button click to accept that. Once that's done, obviously you would do the connectors again, but in this case we don't need to worry about them. I am going to turn off the loads and constraints, and then I'm going to actually go to the mesh pull down and click on the mesh button, which will again show the mesh that was previously created for us. Once that's done, we can go right into the results and take a look at our results from this particular study. Now the first thing is kind of neat to do is just run the animation. It'll put this thing in animation mode, and of course there's some options here for you to look at as it's animating, whether you want it to be animate full cycle or half cycle, and you can turn on and off the contour colors. When you're done running that, you can mention that there are different ways to display the contour colors. The first one obviously does the smooth blend, but we also have banded, which will change the look and feel of that, or you also have the color per element, which gives you a different look and feel of your results. Another thing that's kind of neat is you can turn on the undeformed model, and under the display tab you have full control of the primary display of your results and the undeformed display if it is turned on. When you turn it off, it actually inactivates this. Under the color bar you have several other options that you can change. Maybe you want to change the text color to be something a little bit darker, or maybe you want to change where the actual color bar is. You have full control of all of this information, and we can look at a little bit more of this in a minute. I think one of the key things is the ability to use this probe command, turn on the displacement, and you can actually extract nodal information by just clicking on a node. As I pull it off, you'll notice I can pull off the different information and get a lot better feedback. So we have a lot of information and a lot of control in the simulation results environment itself. Okay, so it looks like we've got some stress here on this shaft. It looks a little bit weak, so we might want to make a change. Well, this is a synchronous, built-in synchronous, and it's an assembly. So what I'm going to do is I'm going to go to the static study 2, which again has already been defined, but we want to make a change to the geometry. So let's change it by going to the faces priority, select the hub, and then once we get into the hub, select the 35. and of course you want the down arrow, and change that 35 to 80 to lengthen the hub. And then we want to make the hub a little bit thicker, so we're going to set that 45 to 70. And then finally the 25 millimeters we're going to change to 50. So this will give the hub and the shaft of the hub a little bit more strength. Now once we've done that, we can go right and show the mesh. The mesh again has already been created, and it will reflect the size that you change that to, and then we can go right into the results of this, which again has already been solved. You'll notice now that that the stress is really focused more on the blade. Blades are a lot cheaper to replace than hub assemblies, so this is what we're looking for. And of course, if I run an animation, it's going to show where that stress on the blade is going to occur when this thing hits a rock. Some other things that are kind of interesting is if you go to the color bar, you can get different feedback on the color bar itself. We have under spectrum, and this might be off the screen a little bit, but you can try it. You can go to grayscale. You can also go to a stoplight if you want to, just different types of feedback. We also have the rainbow. So that type of feedback is capable. If you want to create or generate a report, you can do that. And if you want to browse to find possibly where the possibly add a logo, you can add the Solid Edge Velocity Series logo. It's going to remember this information, so we're going to go ahead and click on Create Report. It's going to gather all of this information from the stress analysis. It's also going to take snapshots of the different results, and then it's going to generate this report for us that we can send to management or to our boss to see if they want to make any changes to the models. You'll notice it comes back and gives us our Solid Edge Velocity series. It gives us a simulation report information, table of contents, so that you can go right to the results and scroll through this information and see pertinent information that you'd be interested in from this report. So again, simulation is a very powerful solution for running an analysis on your assemblies or parts. Of course, we support analysis on sheet metal parts, solid models, and also assemblies, whether it's a linear static study or a modal analysis. With that, this kind of gives you a good idea of how to run through this demonstration. So at this point, you'll want to close the file, probably not save it, go back to your top level assembly to continue on with the next portion of the demonstration.